Alright, to follow up on some of these number theories, we're going to talk about weird numbers and vampire numbers. Okay, weird numbers has two rules. Alright, so a number is considered a weird number if the following two happen. Alright, one, remember we talked about perfect numbers. If you take the sum of its factors, excluding the number itself. If you take the sum of the factors and it adds up to the number, that's perfect. But if it is greater than the number, then it's potentially a weird number. There's a second part to this though. Alright, so you add them up. Alright, then you look at what's remaining, and no partial collection of factors, no partial collection of the factors can add up to that original number. Alright, adds up to the original number. Okay. Alright, so let's give you a couple examples here. 24. Alright, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. So remember, we disregard the factor itself. So first add these up. 1, 2, 3, 4, 6, 8, and 12. If you add those up, that's 36. So it meets the first criteria. It's greater than. However, look, if I take 12 plus 8 plus 4, I get 24. So the second criteria doesn't meet. There is partial factors that add up, so this is not a weird number. Okay? There's not too many weird numbers out there. So let's see. How about, let's try 70. 70 is 1, 2, 5, 7, 10, 14, and 35, and 70. But remember, we disregard the number itself. We disregard that. If you add these up, 1, 2, 5, 7, 10, 14, 35, that adds up to 74. So that meets the first criteria. It's greater than. Alright, so now we have 1, 2, 5, 7. So this adds up to 74. There's no combination, there's no 4, and there's no combination of numbers that add up to 4 that I could take out and get to 70. So no combination of these numbers will add up to 70, no matter how you try it. So this one is a weird number. Okay, so yes, it's a weird number. Alright, there's only a few that we really talk about, so this is something you may want to memorize here. Weird numbers, the first few, there's more, but 70, 836, 4030, 5830, 7192, 7912, and 9,272. Those are some for sure weird numbers. Notice that all of them are even. We haven't figured out, or they haven't, it's unknown, I should say, if weird numbers can be odd. Okay? So that's weird numbers. The next is vampire numbers, which is a very new topic. Vampire numbers exist because there are numbers inside numbers that just blend in, just like vampires do, that you don't realize are there. Okay? The thing with vampire numbers, you have to have an even number of digits. Okay? Even number of digits. So that means 4 digits. Okay? 6 digits is what we're going to do. So a vampire number actually has a product of 2 numbers whose digits are in the original number. Okay, alright, so let's show you a couple of these. Alright, so let's try let's say, how about 1260? That's 4. We're going to deal with 4, sometimes 6, but let's just try 1260. So what you're looking for is two-digit numbers that, when multiplied, will give you this. All right, so I just start off with 12 times 60. 1, 2, and 6, 0. And that's 720, so that doesn't work. Okay, so maybe it's 16 times 20. See, I just went 1620. That's 320, so I went the wrong way. All right, so now I need to maybe do like 61 times 20, because there's 1260. And when I do that, I get 1220. So closer. So how about maybe 60 times 21? All right, that might work. Well, when you multiply that, you get 1260. This is, to me, like a guess and check. So this is a vampire number. Typically what I'll tell you is, hey, this is a vampire number. Find the two numbers whose product gives you that number. Okay, so let's say this is a vampire number. Let's find the two numbers here. Okay, let's find the two numbers. All right, it ends in 5, so to me, one of these have to end in 5. So let's just do 1435, and we actually only get 490 there, so that's not it. All right, so well, let's just flip that 14. Let's make it 41 times 35. All right, I just flipped that. 41, see, I still have the 1435. If I multiply that, I get 1435. So there is the combination I'm looking for. So that's called a vampire number. Vampire number. Okay? All right. We're going to start talking about clock addition here. Clock addition. Okay, clock addition. When we look at this, clock addition is kind of similar to when we talk about different bases. All right. Let's talk about fourfold. We're going to do fourfold first. Fourfold. All right, so the symbol for clock addition is the plus sign with the circle around it, and the circle represents a clock. Okay, fourfold is there's only 4 digits, just like base 4, and those are just like in the bases, 0, 1, 2, 3. So you kind of spread these out in the clock addition so they're kind of symmetric. This is sometimes called a rotational symmetry. All right, we always move clockwise on this. And so what will happen is we would give you some problems here. 2 plus 2 in this. All right, so, whoops, that shouldn't be circled there. But this is 2 plus 2. So it's not 4 because 4 is not one of the digits in fourfold. So what you do is you start here at 2 and you move clockwise and you just go over 2 since I'm adding 2. 1, 2. This is actually 0. Okay, so if I did like 2 plus 3, well, 2 plus 3 is 1, 2, 3 is 1. It's not 5 because there's only 0 through 3 in fourfold. Okay, you can also do something like this. 2 plus 2 parentheses plus 1. Okay, so if I do 2 plus 2, I know that's 0, so this is the same as 0 plus 1. Well, 0 plus 1 is 1. Okay, so that's fourfold. The other thing I could ask you to do in clock symmetry is create the table. And so all you do is you take the digits that are allowed, and in this case it's 0 through 3. You write those up top and you write them as a column, and you create the table. All right, you can actually use the clock to help you out here if you want. I always do the clock, and then I can help fill it. What's 0 plus 0? Just like in regular addition, 0 is the identity matrix, so you just add 0 to it, and it is the same. All right, so 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. However, 1 plus 3 is 4 in base 10, but I don't have a 4. So if you look, if I was up here at 1 and I added 3, 1, 2, 3, it's actually 0. So 2 plus 0 is 2. 2 plus 1 is 3. All right, so hopefully you see a pattern. Look, everything just kind of shifts over to the left for each row, and then this first one goes back to the end. See, the 0 goes back to the end. Everything else shifted over. So this would be 0, 1. This would be 3, 0, 1, 2. Okay, that's really all there is to clock addition. Okay, that's all there is to it. So you'll have problems like this. The thing with clock addition, associative property and commutative property also apply, and order of operations also applies. If something's in parentheses, you must do that first. All right, so you can do 4-fold, 5-fold, 6-fold, 7, doesn't matter. Okay, so it's always, if it's 6-fold, it's 0 through 5. 7-fold is 0 through 6, and so forth. All right, so that's clock addition or rotation symmetry. Okay, so you will have this type of stuff on the quiz tomorrow. Practice the homework, come in with questions first, and then we'll take the quiz. All right, have a good one.